Something meditative and relaxed today, but still interesting, and a product that we're going to be using in some more videos. A while ago a friend donated us a big tub of ammonium chloride, so today we're going to use some of it to create a strong aqueous ammonia solution. Not too difficult to figure out what we're going to do here. We will react the ammonium chloride on the left with sodium hydroxide on the right, which will create ammonia gas. The trick is doing this in a safe way, given that ammonia is pretty toxic, choking, and unpleasant stuff to work with. So let's rock. Here's our ammonium chloride salt, and we're using 94 grams of this, which is 1.75 moles in total. It's just a pretty boring looking white crystalline solid. And here's the sodium hydroxide. We're using a stoichiometric amount, and so 1.75 moles corresponds to 70 grams of solid sodium hydroxide. It's pretty hygroscopic, so we've got it covered in plastic wrap. So ammonia is unpleasant and hard to deal with, but it dissolves readily in water, forming a solution, and so we've measured out 70 ml of water here, and this is what we're going to use to dissolve the ammonia gas in. Although the two solids will react together to a certain extent in the dry form, adding some water will help. What we're going to do is dissolve the sodium hydroxide to form a fairly concentrated solution using some ice and a little water. Stir quickly because you don't want the sodium hydroxide clumping together into a big lump. Okay, so we've got a nice concentrated solution here which should react pretty vigorously and readily with our ammonium chloride. Okay, that's the lineup of the key reagents. Let's get set up for the reaction and go through the equipment. We've rigged up a way to add the sodium hydroxide solution to the ammonium chloride slowly, and leading the ammonia gas produced into the water in the measuring cylinder. We'll go through in reverse. Here's our water in the cylinder so we can see what the volume is as the reaction progresses. We've got a long glass tube leading into the water. This is connected to a hose, which goes back to an arm of a gas generation flask. You'd better believe we're using plenty of silicone grease for the joints for this reaction. We've got the 500 ml 2-neck flask set up on a hot plate. And on top of this we've got an addition funnel for the sodium hydroxide. As you'll see later, it's not perfect, but it should work okay if we're diligent and careful. Let's check it's airtight. Perfect. So we're ready to cook. Step 1, we'll load up the flask with the ammonium chloride. Step 2, load up the sodium hydroxide solution into the addition funnel. We'll start off without applying any heat to the flask, and slowly add the sodium hydroxide. We're also going to be careful and watch the reaction constantly. Ammonia gas is extremely soluble in water, and this can lead to risk of suckback where the water in the cylinder comes back up the hose. If we were going to be extra careful, we'd use a water trap to stop this, but we don't have one. So we'll be keeping our eye on the gas level in the glass tube to make sure the water doesn't creep up. Okay, let's do this. We're getting bubbles, firstly of air being displaced from the flask. Watch what happens to these as we proceed. Some interesting sounds coming from our addition funnel. Ideally we'd have used a pressure equalized one, but our PE funnel is still in deep storage at the moment. Still lots of air being displaced. The reaction is pretty smooth, no foaming or out of control gas evolution. See the size of those bubbles getting smaller? As the ammonia gas comes into the water, it dissolves pretty much instantly, leaving only any residual air as a bubble rising to the surface. We're going to make sure all the rest of the sodium hydroxide solution is added now, and we'll start heating the flask. The aim is to eventually heat it to just below boiling point of the solution, perhaps around 80 to 90 degrees C, as this should drive off most of the ammonia. There's something kind of meditative about sitting here watching a nice reaction and the gas slowly bubble into the water. Next thing you'll notice is that as the ammonia gas dissolves in the water, it actually heats up the solution. We've got a thermometer in here tracking this. It's starting to get pretty warm. So we're going to instigate some DIY cooling measures. It's crude, but it slowly works. This is starting to heat up and the gas generation is still pretty steady. Here we are about an hour and a half in. Remember how we started with 70 ml of water? Well, now we're up to over 90 ml of liquid. As the ammonia gas dissolves, the volume of the solution expands a bit. You can see the bubbles of ammonia dissolving into the solution. After about 2.5 hours, the gas evolution has slowed right down, so we're going to stop here. Once you remove the heat, be super careful with the liquid level in the tube. It's going to sneak up and back into the flask, unless you stop it. We released the addition funnel tap, so the flask is now open to the atmosphere. We can tell that the cylinder contents smell very strongly of ammonia, but apart from that we've had no issues with gas leaks or any strong unpleasant ammonia aroma. You can see the sodium chloride reaction product as fine crystals in the reaction flask. Okay, so here's our product, aqueous ammonia in the measuring cylinder. 96 ml of liquid, which started as 70 ml of water. Let's get this into a clean airtight storage container, and we'll also weigh the product in order to help us estimate the concentration of ammonia in the solution. 86.4 grams, giving us a density of 0.9 grams per ml. There are a few ways to calculate or look up the concentration. Doing this by mass of ammonia gives us approximately 20% concentration. Doing this based on the solution density gives us approximately 23% concentration. To know, we'll have to titrate it using acid and a suitable indicator, which we don't have at the moment. Maybe we'll come back to this in a future video. But this gives us a useful indication, and we'll be using the solution qualitatively, so that's good enough for the moment for our purposes. Okay, let's have a bit of fun with the product before we wrap this up. Okay, looky, we've got an open bottle of hydrochloric acid here. The vapors of each chemical generate ammonium chloride as a white mist in the air. Always fun to watch. Now let's try a reaction. Here's a dilute solution of copper sulfate in water. Let's add a few drops of the ammonia solution. To start with, we get a pale blue precipitate, which is copper 2 hydroxide, generated by the strong alkaline nature of the ammonia. but you can also see a deeper blue color as well. As we add more ammonia solution, the precipitate dissolves again. A beautiful deep blue color, caused by the formation of a copper-ammonia complex which is formed. Ammonia is pretty good at complexing transition metals, and this can use a useful and interesting property. Okay, that's a wrap for this video. We're going to be doing some work to replenish our stocks of useful reagents because we feel like some more videos coming on shortly, so do stay tuned.